All right, moving on to volume and surface area of pyramids and cones. These are the last shapes we're doing. We're going to divide volume and surface area up into two different sections. So this is just volume. Okay, so I think you guys would agree if I asked you this shape, you would call it a pyramid. And you know we like to make the difference between the bases if they're any shape versus circular. So if it's a circular pyramid, then we call it a cone, right? It looks like an upside down ice cream cone. All right, so some of the things that we already know. This is going to be your base. It could be a rectangle, a square, a pentagon, a hexagon, any number-sided shape. As long as it's not circular, then we call it a cone. So again, this is capital B, and remember that capital B stands for the area of this base, right? And over here, capital B is just going to be the area of that circle. And again, it'd be the area of all of this. Okay, and then height of the pyramid or cone. Height comes down from the top and goes straight to the middle of the base and meets at a right angle by definition. So same thing over here. The height goes straight down to the middle of the base and meets at a right angle. Okay, now if this is a volume, then of course the units are cubed. Okay, so that's for both of them. And then here are the things that we need. We're going to say capital V, volume, for a pyramid is 1/3 capital B times H. Remember, capital B stands for the area of the base. Area of the base. So knowing it's the same equation over here, but just compensating for the circle, it's going to be 1/3. The area of the base, since it's a circle, is pi r squared, still times that h. All right, so now it's just practicing and realizing what these are called, each shape. So realizing that is a pyramid first would be the first thing you would do. If you know the equation for the pyramid for volume is 1/3 capital B times H. And on this one, let's give you 5 inches here, 4 inches here, and 7 inches here. All right, so if I asked you for the shape of this base, hopefully you would tell me this base based on the 5 and the 4 being two different lengths, that you would tell me that's a rectangle, right? So the volume is going to equal 1/3. The area of a rectangle is just the 5 times the 4, right? The base times the height for the 2 dimensions, times the height, this h, times the height of the pyramid, which is 7 inches. Multiply those together, always rounding to the nearest hundredth unless we tell you otherwise, would give us 46.67 inches cubed. All right, next, got shape. You should first identify as a cone. And therefore, if I give you information, can you fill in volume equals 1/3 pi r squared h? All right, for this one, let's give you that this is 12 centimeters and this is 15 centimeters. Now, I hope if I asked you, if you were about to fill in this equation, do we have all the information or do we need to find something? I'm hoping that you would notice we still need to find the radius. So the radius would go from here to the edge. By definition, we said the height comes from the top down to the middle, meets at that right angle. So of course that's meeting the radius. So we really should be focused in on this right triangle that I've just drawn in pink. You have 2 out of 3 sides of a right triangle. Again, that stuff's not going to go away. It's back to reducing triples Pythagorean theorem. So if you took and reduced this by 3, you would have 4 and 5. That is a triple because 5 is the hypotenuse. So this side would be 3 times 3, or 9. And maybe I'll circle those bigger lengths just so that we remember that's what we have to use. We can't use the reduced numbers. We can't change the size of this cone. So volume is 1/3 pi. The radius is 9 that we're squaring times the height of the cone, which is 12. Answers in terms of pi and decimal, please. So I would do 9 squared is 81 times 12, push equals, divide by 3, push equals. That will give you 324 pi centimeters cubed. Take that number sitting on your calculator, multiply by pi, and decimal answer would be 1017.88 centimeters cubed. All right, that last shape, identify that first of all as a pyramid, and then look up your equation. Would be volume equals 1/3 capital B times H. Once again, we will give you this information. Let's say 16 feet, 16 feet here. And carefully, I'm pointing to that mark right there. We'll say that's 17 feet. All right, so if I'm thinking about filling in this equation, I have the base labeled, right? 16 by 16 means it is a square this time. What I don't have is the height. So I need to draw that in the picture and find that first. We said by definition, height comes straight down from there, goes to the middle of this base, and it meets at a right angle. Well, if it's meeting at a right angle, guys, we're talking about this part being a right angle. And I claim if you look at this triangle that I'm now highlighting in pink, this right triangle, you know 2 out of 3 of those sides. The hypotenuse for the triangle is 17. I claim you also know this length. Because if it goes from the center of this square out to this edge, right? This line is parallel to both of those sides. Isn't it exactly half of this side? It would just be 8 feet. And now reducing triples Pythagorean theorem, 8 and 17 don't reduce, but they are a triple. 8, 15, 17 is that triple. All right, so I think we have everything that we need now. Our volume is going to be 1/3. The area of the base being a square, you would do side squared, or 16 times 16, however you want to write that, times the height of the pyramid, which is 15. And that answer would be 1,280 feet cubed. All right, that is volume of pyramid and cones, and we will do surface area in a different section.